This lesson we'll be talking about substitution. We'll solve for a variable. Students should be able to solve systems of equations using algebraic methods, use the substitution method, and solve real-world problems. So steps for substitution. You need to choose one of the equations, it doesn't matter which one, and solve for the variable x or y. You need a coefficient, so choose the one that's easier. Plug it into the other equation, distribute, combine, and solve. Then remember, at the end, you have to plug your answer back into the original equation to get the other variable. Your answer is always an ordered pair. So if there's one solution, that means the lines cross. And if there's no solution, it means that the variable has been eliminated. So you did your equations algebraically, and you get a false statement. And then infinite solutions means that you've eliminated the variable and you get a true statement. So for example, solve the systems of equations using substitution. So since this one already says y equals, I'm going to plug this in for y. So it's going to be 3x minus 16 minus 2x equals 4. So we're going to distribute 3x minus 16 plus 2x equals 4. Combine like terms, 5x equals 20, so x is equal to 4. And then I can plug it back into either equation. So I'll do this one, y equals 16 minus 2 times 4, so y equals 16 minus 8, so y equals 8. So my solution is 4, 8. Okay, this one already says y equals, so I'm going to plug this in for y. So 6x minus 2 times 3x plus 2 equals negative 4. So 6x, I'm going to distribute, minus 6x minus 4 equals negative 4. Combine like terms, and I get negative 4 equals negative 4. And that is a true statement, so my answer is all real numbers. Which means that the lines, if I put them both in slope-intercept form, we would have seen that they have the same slope and the same intercept. All right, this time I've got this y equals, so I'm going to plug this in for y. So 3x minus 5 times 3/5 x equals 15. So 3x minus 3x is negative 5 times 3/5 is negative 3 equals 15. Combine like terms, and I get 0 equals 15. Since 0 does not equal 15, that means it's an empty set or no solution. Which means if I put them both in slope-intercept form, I would have seen that they have the same slope, but different intercepts, which means they're parallel. All right, Alfred has 9 pencils and pens. He has twice as many pencils than pens. How many does he have of each? So first I'm going to define my variables. So I'm going to say x is pencils and y equals pens. Then I need to write my two equations. I know that they both equal together, they equal 9. And I know that there are twice as many pens as there are pencils. So this goes in for y. So I get x plus 2x equals 9. Combine like terms, 3x equals 9. So x is equal to 3. So I plug it back in. Y equals 2 times 3. So y is equal to 6. So my solution is 3 pencils and 6 pens. Remember, it's a word problem, so it needs words in the answer. 253 tickets were sold for a Saturday evening performance of the play. The tickets cost $9 for adults and $4 for children. The total was $1,963 for all the tickets sold. How many adults and how many children attended the play? So the first thing I need to do is define my variables. So I'm going to say A is for adults and C is for children. So I know that 9 adults and 4 children cost $1,963. And I know that the tickets total sold were 252. So I need to change one of these to the variable by itself. So I'm going to subtract C from both sides on this one. So I get A is equal to 252 minus C. Now I can take this and plug it back into there. So I get 9 times 252 minus C plus 4C equals 1,963. Use the distributive property, get 2,268 minus 9C plus 4C equals 1,963. Then I'm going to combine like terms, so I get 2,268 minus 5C equals 1,963. I subtract 2,268 from both sides. I get negative 5C equals negative 305. Divide both sides by negative 5, and I get C is equal to 61. Now I plug it back in, and I'm just going to use the easy one of A plus C. So A plus 61 equals 252. So I subtract 61 from both sides, and I get A is equal to 191. So that means 61 children went, and 191 adults. If there's no solution, what kind of lines do you have? They're parallel. If there's exactly one solution, what kinds of lines? Intersecting.